Good afternoon, and welcome to the Society of Wetland Scientists January webinar, where we will be learning about enhanced mapping tools to protect and restore Vermont's wetlands. My name is Louis Mantini, and I'm currently a member of the SWS Webinar Committee, and I'm going to be your moderator today. Before we get started, I'd like to go over a few housekeeping items. The general format for today's webinar will be a 45-minute presentation by our speakers, followed by approximately 15 minutes for questions. At any time during the presentation, you can type your questions in the questions pane of your control panel, and I will pose the questions to our presenters at the end of the presentation. This webinar is being recorded, and you'll receive a link to the recording following the webinar. We also ask that you take a moment to complete the evaluation survey that will help us plan future events. If you would like a copy of today's slides, please find a PDF copy in the handout section of your control panel. And if you're familiar with Twitter, you can tweet about today's webinar at hashtag SWSwebinar. We're proud to announce that this webinar has been pre-approved by the SWS Professional Certification Program and is applicable for continuing education credits that can be applied to your Professional Wetland Scientist certification or renewal. Participation certificates are now available through an automated process. You will receive an email from Michelle Chosak, our SWS Executive Director, about 1 day afterwards. So check your spam email if you don't see it. To access the certificate, members should log into our SWS store. Once logged in, they will see that the certificate access item can be purchased for $0. Participation certificates are also available for those who watch webinar recordings, which can be found on our past webinars page. So with the logistics out of the way, let's get started with our webinar. Today our speakers are Julie Follansbee and Brock Freer, both of Vermont Department of Environmental Conservation's Wetlands Program. Julie has served as a district wetland ecologist with the department for 12 years. The position protects Vermont's wetlands through regulation, education, restoration, and enforcement. As program restoration specialist, she reviews potential wetland restoration projects, collaborates with state, federal, and NGOs, advises restoration bioassessment, and is developing a statewide tracking system for wetland restoration work. Brock currently works to protect Vermont's wetlands as a district wetlands ecologist for the department wetlands program. In doing so, he collaborates with state, federal, NGOs by providing regulatory, technical, and moral support. Prior to his work in Vermont, he's bounced around the United States, wandering in wetland and riverine systems, hoping to keep his feet dry in wet spots. No matter where he's working, he's constantly intrigued by the working landscape and how our activities have altered the natural systems present. Through a hydrogeomorphic landscape scale lens, he looks for opportunities to restore and enhance these potentially degraded systems. So, with that introduction, I'd like to turn control over to Julie and Brock.
Great, thanks Louis for that introduction. This is Brock sitting here with Julie. Thanks for joining us today for our talk about enhanced mapping tools to protect and restore Vermont's wetlands. Let's see. Here we go. Thanks for control. So to start you off, I'm just going to kind of give you guys a little crash course about wetland regulations in Vermont and why we protect wetlands in Vermont. In 1990, the Vermont Wetlands Rules was enacted. It protects significant wetlands, which are called Class 2. So if you hear me say Class 2 wetlands a lot, those are the protected wetlands throughout Vermont. Class 2 wetlands, we apply a regulated 50-foot upland buffer around them. So you can see the map there. You have the delineated wetland with its 50-foot buffer. So anything within that 50-foot buffer is is regulated by the Wetlands Program. Wetlands in Vermont, we protect them with 10 functions and values, ranges from storm water, erosion control, recreation economics, as well as more subjective things such as open spaces and aesthetics. It's important that we measure and scale these because this is how we determine whether a wetland is class 2 or not. And just as a little extra background, we also have class 1 wetlands, which are exemplary, irreplaceable wetlands. So this is cream of the crop, the nicest of the nice. And then there's also class 3 wetlands. These wetlands typically found in like farm fields or really small, and they may or may not provide one or a few of these functions, but they provide them at a significantly diminished level. So, you know, these ones are less warranted of protection. The majority of wetlands in Vermont are what we call class 2 and are protected by us. Vermont's fortunate, and we have unique and diverse topography as well as geology. We have lots of rain here, so we have lots of different types of wetlands. We have a lot of very unique forested swamps, softwood, hardwood ones, scrub shrubs. We have buttonbush swamps, America Gale. We have emergent marshes. We have different types of bogs. We have multiple fens, rich and poor, depending on the groundwater and underlying geology. Lots of lacustrine fringe wetlands. You got to think about Lake Champlain and its size. I mean, it's kind of a petite Great Lake of sorts, and we have some phenomenal lacustrine wetland systems that are certainly very unique to our area. We have wet meadows. I put ish there because this is a different topic, but given our forested state, sometimes I wonder if our wet meadows are just a transitional thing from past land uses and are just waiting to go back to scrub shrub or to forested. We also have clay plains, sand over clay plains. These are pretty unique for us because of our past glacial and inland sea, when the Lake Champlain was inland sea and deposited lots of marine clays, and then subsequent glaciations deposited sands over them. So really cool communities, really neat soils. And then when you get into the Greens and the escarpment and the Piedmont area of the Greens, we have so many seeps, springs, and mosaic wetlands. Given Vermont's past and current agrarian lifestyle, we understand that this is a living and a working landscape. So among those other really nice wetlands, we also realize we have nice restored wetlands. We have logged wetlands, drained and filled wetlands. You gotta mind the buffers here. So we also have altered buffers, developed wetlands, and plenty and lots of farmed wetlands. So given all that diversity and change in such a small little state, how do we track these and how do we let the public know where they may not occur? The Agency of Natural Resources has compiled most all of our data into the spatial references through the A&R Atlas. This includes watershed management, which is the division we're under, but also waste management, stormwater, rivers, geology, parks and rec. The list goes on and on and on. Lots of data. So what we're able to do is, from this huge data set, is glean the stuff that is pertinent to wetlands and or wetland ecology. Vermont Fish and Wildlife provides some great data sets. A lot of these data sets cover significant natural communities. So again, think of like the really nice, pristine wetlands. They do a good job of cataloging these. Here in this image, you can kind of see where they're that richer purple color. We also have rare, threatened, endangered species, which they've cataloged in the field, and then make what are called EO element occurrence reports for us to read. Whereas you can see the general location of the natural communities, most of the rare, threatened, endangered species, those floating polygons as they are not available to the public, obviously, to protect that resource. And then we also have the uncommon species and other features that are highlighted, and those are in the light blue that you see in that image. These are important for us to keep on here because you got to think back to the 10 functions and values, and significant natural communities, RTEs, the rare, threatened, endangered species. Those are all things that we protect wetlands for. So if one or two of these are present in a wetland we find, that further justifies our protection of that wetland and providing it with a Class 2 status. Two other programs that provide a lot of great data sets that we're able to utilize are the Rivers program. They map floodways, hazard areas, river corridors. I mean, in these areas, you got to think floodplain forests, frequently flooded areas, riparian wetlands. These are areas where water is and always will be since the river courses are there. So just knowing where the water is helps us and the general public understand the potential of wetlands and the type of wetlands that might be present. Lakes and ponds. There's lots of lakes and ponds as well. You know, going back again to Lake Champlain, you can kind of see Lake Champlain in this image here is the darker blue. They've done, Lakes and Ponds have done a good job of mapping this and then also showing where their protected shorelands areas are. Lakes and Ponds, they protect there's a buffer from jurisdictional lakes and ponds. Within these buffers, again, close to water or water's coming off of the topography, there are plenty of wetlands. So these are indicators for us and the general public to help us understand where prevalence of wetlands may or may not be. Both these programs also map priority water bodies, impaired water bodies, and outstanding water resources. Each of these layers provide us more information again for classification and knowing the importance or the function value of a wetland present if it's present or adjacent to these features that are mapped. Vernal pools is also a huge data set. Now, mapping vernal pools through polygons is difficult due to their size. Here you can see an image it's borrowed from the Vermont Center of Eco Studies, but you can see the amount of confirmed potential and then surveyed vernal pools throughout the state of Vermont. Again, since we have such a unique and diverse superficial geology, a lot of these pools in different regions provide very unique habitats for different sets of salamanders or breeding amphibians. The original data set was compiled in 1995. It was revised and updated in 2013, and it's currently being reprocessed by the Vermont Center of Eco Studies, going out and surveying and confirming pools. Some of the pools in the 2013 were suspected pools, and if they're able to get on those parcels and were able to confirm or deny or find others, those were added or deleted from that data set. So in time, once they're done with their project, we hope to update this data set so that it reflects the resource appropriately. So now you're thinking probably back to that original A&R Atlas and you're like, wow, like all these things are probably buried in all the different tabs, you know, wastewater or drinking water, fish and wildlife, etc. So IT here at Agency Natural Resources worked really hard to compile all this data that is wetland related or wetland dependent and is compiled them into what we call the Wetlands Inventory map. So it's kind of your one-stop shop for all geospatial wetland data in Vermont. It's really nice. There's a link down there to the website, but if you visit the DEC's Department of Environmental Conservation Wetland Program site, there's links there too for the inventory map. Here, when you open it up, you can see all the different data sets that are available to us. You know, if your house or home or project is in or near any of these, you potentially you should certainly be giving us a call just to review the project, make sure that no permitting or guidance is needed. This is an exceptionally wet picture here. The whole state doesn't look this wet, but this is the Missisquoi Bay, which is actually it's a Ramsar site. It's Vermont's only Ramsar site, but it's a phenomenal wetland and wildlife refuge in the northwest corner of the state. So within this data set, which is also available in the ANR Atlas, we have very wetland specific layers. There's the VSWI, which is the Vermont Significant Wetlands Inventory layer. This layer is unique in a way that this is a jurisdictional geospatial layer. So by that, I mean anything that occurs within or is contiguous, a wetland that is contiguous to these falls under our jurisdiction. Pretty much no question. So you certainly, a landowner or a town or municipality has a proposed project or wants to alter the landscape in some way. If it occurs within one of these teal polygons, you can see there within those beachish tan ones, which are just hydric soils. If you have anything in those teal polygons, give us a call. Those layers are originally derived from the original NWI data set, but they can be updated and changed through Vermont wetland rule changes. That's an act of legislation, and it's long and arduous, so that doesn't typically happen. The last time it happened was in 2010. But it can also change during permit actions when we receive review and understand where delineated wetlands are on the landscape. This can also be done, these changes in the VSWI can be done through petitions. And through these petitions, we can add, remove, reclassify, think, you know, class 1, class 2, class 3. And we can also alter them because the original NWI data set didn't always provide the best coverage for the resource present on the ground. Another wetland program specific spatial data set that we have are what we call the wetland project stars. These stars are forward facing as with all this other data, and they provide a spatial reference of where wetlands program staff has been or has reviewed. So again, you know, if something's not mapped, it's not hydric, there's no signs of it, but you see one of these stars, it gives you a clue or inference that someone from the wetlands program at some point has looked in here. And this backtracks to our database so that we're able to go through and review things. And in the long run, it saves a lot of time. It helps us understand what's going on in the landscape. And then it also gives us a way to catalog wetland delineations and other surveys that may or may not have occurred within these project stars. So this is where the project stars and edits and changes get really fun for us. We also have the VSWI advisory layer. Essentially the same as the VSWI layer, but this is a non-jurisdictional wetland mapping tool. This is a wetland layer that we are able to amend on the fly or as we see needed. If other data sets such as NWI updates are available to us and rule changes aren't available to incorporate those, we can do wholesale additions to those. Towns typically throughout Vermont, they have conservation commissions that will contract out a wetland scientist, and they'll do or a wetland ecologist, and they'll do a town-wide wetland mapping project to update these VSWI polygons because they understand they don't provide full coverage, and these towns are concerned that, you know, they want their town folk and landowners to understand where wetlands occur on the landscape. We also have a great data set from our bioassessment team that goes out and annually reviews and provides assessment, very fine-tooth comb assessments of wetlands throughout the landscape. And the result surveys provide us with very high resolution wetland mapping. We can add those to the advisory layer as well. And then we also get things from like landowner notifications, and they're like, hey, I don't have a wetland, or hey, I have a giant wetland. Can you come out and look at it? Or, you know, I have this mapping for you. We're able to add it through those ways. And then Heritage also provides us, through Fish and Wildlife, provides us updates too. One big addition that we're really excited about is the Missisquoi River. So I showed you that the Missisquoi River delta earlier, and you can see obviously how wet the delta is. The watershed that feeds that delta is a mountains to lake system. So you have a very diverse terrain, from forested mountains to flat clay plains. Lots of variable land uses. We have logging untouched. There's 2 or 3 moderate-sized towns. Lots of farming, and then there's also just the past land use. Most of Vermont in the 1800s was cleared and used for sheep farming. So just lots of different things going on, and then also the unique hydrology of the area. Anytime you go from a high point in a watershed down to a low point, especially from a mountain to a large lake, you have your seeps and springs, and then you have your large rivers and ponds in between, and then you get to the glacial outwash areas towards to the Lake Champlain Basin. You have clays and outwashes. So the hydrology and how water moves through this entire watershed is pretty unique. And then also the assorted superficial geology, as I just said. The result of that was the original NWI mapping way undermapped this area. In this area, given all of its pressure and its diverse land uses, it's critical for us to provide the public with a much better data set. So what we did was we applied for a grant, and we were able to hire St. Mary's University of Minnesota to update the NWI polygons throughout this watershed. And then through that, they're going to add the NWI, they're following the NWI plus protocol. So they'll be adding landscape, landform, flow path, water body coding. And they're doing this through collaboration with us here at the A&R staff. So this summer we provided ground truthing. We've provided additional mapping where we know present. Those project stars have helped guide a lot of absent presence of wetlands where they may or may not have been mapped before. So we're really excited to get the final product for this, and then this will likely go. We'll update this, and this will be added onto our advisory layer. So yeah, so this is kind of similar to what we did. We have a great LiDAR data set. Charlie Hone is our wetland bioassessment staff member, and he's a phenomenal mapper, especially with LiDAR. I added some of his color-coded psychedelic LiDAR polygons here just so you guys can see how he works. And then the 2 in the middle there, just kind of how we ground truth stuff is, we were fed stuff back, and then we went out and ground truthed them and did either these pictures with hand sketches, or went back to the office and provided feedback through just edits to the polygons. So in time, is there going to be more wetlands mapping? Charlie there, he seems questionable, but we all know that, yes, there's going to be a lot more. We're going to get this final submittal of the Missisquoi Basin, so that we'll be able to add NWI plus to this area of Vermont, and hopefully it'll just be the the stepping stone for the rest of the state, as well as updating the advisory layer there. It's our understanding that UVM is working to provide automated mapping products. So we're really excited to see that develop and progress in time, and see what they might be able to provide us and the people of Vermont to help understand where wetlands may be present. And then just continuing advisory layer updates. Every regulatory site visit we have, every bioassessment survey we have, we're able to go back in and add those into the advisory layer and edit other layers. And then we also have relic delineations and project stars dating back from 1990 that are paper files that we're eager to get to and represent on the map, so that people have a better understanding of where wetlands are, so we can continue protecting the wetlands that are present. Another great data set that we have that Julie's going to tell us about is a data set that was developed to target wetland restoration sites in the Lake Champlain Basin. Thanks, and here's Julie.
Thank you, Brock. So as Brock mentioned, we're on year 11, essentially, of a wetland restoration model development. What I'm going to talk about today is, just a brief intro to build off of what Brock has said. I'm going to talk a little bit about restoration benefits and opportunities, and then get into the specifics of this restoration model to talk about site selection and ranking, and as well as a recent model refinement and some tools that we're using for outreach. So in Vermont, we lost approximately 35% of our wetland acreage before 1980. And today, nearly 50% of our historic wetland area has been lost or impaired by draining, dredging, filling, or excavation. Agricultural conversion is ongoing. It's sort of a part of our culture and history of the state, and agriculture is just a really important part of Vermont. In other parts of the country, we improve or create agricultural lands by adding water to the landscape. In much of Vermont, the historic practice is to drain lands, to drain our bottomlands, to create good agricultural land. We also have increasing development pressures in Vermont, but the good news is that our regulatory protections and tools like the mapping tools that Brock described are improving over time. And we have a lot of folks throughout the state that are doing great conservation and restoration work. And the good news is that all this historic conversion can also be seen as opportunities for restoration. One of the most commonly cited functions of wetlands is their ability to maintain and improve water quality of adjacent streams, rivers, and lakes. Surface runoff often flows through wetlands prior to discharging into waterways, and the phosphorus containing sediment in the runoff is deposited in riparian areas as it flows through wetland vegetation. The associated pollutants can then be absorbed by the vegetation through nutrient uptake, and in addition to water quality and flood storage benefits of wetlands, Brock mentioned that we protect 10 different functions in Vermont, and there are a lot of associated functions and also benefits to wetland restoration. I want to just quickly describe a quick case study that the University of Vermont did. We had a lot of damage during Tropical Storm Irene in 2011. And the Otter Creek flooded in the town of Rutland with 19,000 cubic feet per second of water that went through Rutland on August 28th. It was the highest flow ever recorded. But at 30 miles downstream of Rutland and Middlebury, there was very little flooding. And the flood peak reached Middlebury 6 days later. It had dropped from 19,000 CFS to 7,000 CFS, again over the distance of only 30 miles. Between the two towns lies the Otter Creek Swamp Complex. This has been a focus area for wetland restoration for a number of years. The wetlands slowed down the flood pulses, they decreased velocity and reduced erosion. So in Vermont, we have University of Vermont and others have been studying the role that wetlands and floodplains play in phosphorus retention. And we understand that it's very important. And to the point that in the Lake Champlain TMDL, its wetland restoration has been identified as a necessary component to meet the TMDL goals for cleaning up phosphorus in Lake Champlain. But the key is that wetlands can't provide the function if they're degraded or overwhelmed. So we have revisited a 2007 model to try to identify priority areas for restorations. And in our case here in Vermont, those areas are typically lands that were historically farmed and have had hydraulic or hydrologic modifications, typically ditching, land leveling, and stream straightening. There was a 2007 project that was a partnership with the State of Vermont. We had consultants and then a large team of advisors and stakeholders work on the development of a Lake Champlain Basin wetland restoration plan. The plan identified wetland restoration opportunities throughout the Lake Champlain Basin with the goal of reducing phosphorus to meet TMDL targets. And as you can see from the map in this slide, the Lake Champlain Basin is quite large. It is about half of the state of Vermont. It covers the western most portion of the state. And the model was a two-phase GIS-based model. The first step in the model was to identify potential wetland restoration sites. The metrics used were areas greater than 3 acres in size, hydric soils areas, slopes less than 5%, and open space or open land use land cover data, as well as the NWI impacted wetland layer. And the result was just under 5,000 potential wetland restoration sites. Some of them were quite small, as small as 3 acres in size. And it was essentially a preliminary set of potential agricultural and other open area sites for wetland restoration. The mean size of the polygons that were created from this exercise was 18 acres and covered a total of 135 square miles or 86,000 acres of potential wetland restoration sites. From there, a quantitative prioritization model was developed to rank the potential of each restoration site to mitigate PE loading, phosphorus loading to Lake Champlain based on 11 variables that you see here, focusing on site function and upslope drainage. Site function reflects a given site's suitability for wetland restoration in the context of phosphorus retention and focuses on factors related primarily to soils and hydrology. The upslope drainage factor reflects a given site's drainage area for its potential to transport phosphorus to the site. So focusing on the factors in the areas upslope of a given site, such as land use and soil erodibility. And then those 5,000 or so sites were broken out into quartiles and essentially ranked from highest to lowest, and then color coded. There were a couple different map products that came from this. This is an example of one of the map products. And so what you end up with is mapping, GIS-based mapping tool that identifies wetland restoration sites, as well as ranking them for their ability to mitigate phosphorus. And then a team of ecologists and consultants looked at the top 200 sites and were able to get out and field assess 82 of them, as well as doing a detailed desktop imagery review of those top sites. And the consensus at the end of this exercise was that the mapping was pretty accurate in order to meet the needs of outreach and identifying potential sites for additional outreach. So there's a renewed focus now in achieving our TMDL goals for Lake Champlain, with the focus being on phosphorus and a recognition that wetland restoration is going to be an important requirement of meeting our TMDL goals. So rather than reinventing a model, given that we had one from 2007 that was quite robust, we hired a consulting team funded by a grant through the USDA Natural Resource Conservation Services Regional Conservation Partnership Program, or RCPP, to revisit that 2007 model data, and particularly with an eye to updated land use land cover data sets, but also to see if there was a more effective way to look at that model, the original model output, for the purposes of outreach. And then we added a second, more detailed site assessment piece that I'll explain as well. So generally, the updates related to revisiting that land cover change, reassessing the site groupings, and also revising the prioritization or ranking of the sites. As it turned out, when we looked at the land cover change, it was pretty minimal. There weren't large-scale changes or conversions from agriculture to residential or vice versa. So that wasn't a significant issue with the original data or an update. I would say the majority of the effort and the real value of this update was that the original polygons were looked at a little more closely, and this particular image is an example of what that original model might have looked like, the output, with very small but maybe proximal polygons or sites. So in the original plan, each of these polygons was considered a restoration site by the model and was ranked as such. When we sit down and look at this data, and you look at these maps, and you look at this field, and you think about how wetland restoration happens and the scale that it's most effective, we realize that each of these individual polygons really collectively together are one polygon or one project. And so the team that was working on this project went ahead and lumped sites or polygons that were within 100 meters of one another and called them a single site. And then if there were polygons that extended over roads, public roads, or across large streams or rivers, those polygons were split with an assumption that would not always hold true, but I think is fairly accurate, that land ownership is less likely to extend across a large river or stream or across a road. So those polygons were split. And what the result was essentially larger conglomerations of polygons or larger potential projects. And then with those new polygons or those new groupings, the team recalculated the phosphorus retention score and gave it a 60% weight, added a weight to the size factor, and added a small weighting to floodplain or river corridor proximity or overlap. And like the original model, a data layer was created. Arrowwood Environmental created a web tool that allows, it's a viewer tool for all of the polygons across the watershed, for all of the sites. It provides easily accessible metadata and scoring information for those sites. And then for some select number of high-ranking sites, a much more detailed review was done, and that information is also available on their website. I have the link here. We have since added the base data layer to the A&R mapping sites that Brock had mentioned earlier. And that's for public, public access, public accessibility. A second phase of this project, a deeper dive really, was doing a very detailed desktop analysis of the top 200 sites. We had 3 priority watersheds that we focused on, and there were a few select individual sites that maybe were not the highest ranking sites, but generally it was 250 of the highest ranking sites were given a deeper dive, and that desktop review resulted in a project profile for those 250 sites. And the idea is that these project profiles are essentially an outreach packet for a conservation or restoration professional who may want to do outreach to landowners. So in the case of this image here, this is just one of a handful of maps that were created in this project for each of these 250 sites. It shows a proposed restoration conservation easement boundary. There are 5 property parcels here with the associated landowner information available also within the project packets. So this would be another page of information within these profiles. We provided existing condition information, so what the agricultural condition of the field is, are there ditches, are there natural wetland areas, are there existing easements on the land held by others, and then also identifying what wetland restoration activities may be good options for this site. And again, the idea would be that somebody could take this either in terms of identifying conservation entities' priorities and looking at these sites and learning more information about them, or for outreach professionals to reach out to see what sort of landowner interest may be available. Of course, we also need money and programs to pay for the restoration. And so there are programs like NRCS's Wetland Reserve Easement program that is doing really wonderful wetland restoration work in Vermont. We also have conservation partners like the Nature Conservancy and others who are doing wetland conservation work on the land. So in terms of next steps, we're, as at the DEC, we're looking to secure additional funding for ourselves or partners to do more wetland restoration and conservation work. We are trying to get the word out about these tools and restoration opportunities, and also the benefits of restoration to the wider public. And then one last little project that we initiated last year is to further assess restoration success through biomonitoring. We have an established bioassessment program here in Vermont, and we are applying that methodology to a select few restoration sites that either are soon to be restored or have just been restored, and we're hoping to track those sites over time to see how the land develops and see if we can create some metrics of restoration success through that project. So we thank you all for listening today, and we thank our internal and external partners for their hard work to protect and restore Vermont's wetlands and all of our wetlands. We welcome questions or comments from you all. Thank you.
All right. Can you hear me?
Yes.
Yes.
Okay. This is Lewis. Thank you so much, Julie and Brock. This is an awesome GIS presentation. I just love the way you split it up, between the restoration analyses and potential or mapping tools for that, and then the other, the information that you provide to the public otherwise. And I think if I could, so I'll advance just to let everyone know that we have on this frame both Julie's and Brock's contact information. If your question doesn't get answered today, or if you have one preying on your mind after this whole presentation is over, please copy the presentation and use the contact information here to send either of them email. I think I'd like to start just with a couple of my own questions, and to begin with, Brock, we have tools available to staff at the agency where I work, and as I guess a former regulator, I always wished that we had something like you have as far as your wetland inventory map for people to log on to I guess maybe ArcGIS Online or something like that. But it seems to me like a lot of times when we share information like this to the public, they need a lot of help in navigating these tools. And I was just wondering what kind of feedback you get from folks that actually go online to your inventory map and use it and see if they how user friendly it is, and how much is there too much information, not enough information, or just kind of curious, do they consult that information before they call you in the first place?
Yeah, it's a great question. Best way to answer that is a little bit of both on everything you said. Certainly, even with our refining just the wetlands inventory map of just wetland specific things, individuals are overwhelmed with the amount of data. Conversely, there are other people that realize that the data sets just aren't as thorough as they should be, just because there is the difficulty of mapping and providing spatial reference for this type of resource. So that at times, can be problematic. In general, the public has been very open to this format. We provide a lot of outreach and training to help individuals, towns, municipalities, entities. We work with like, realtor groups, developers, loggers, etc., and provide training on how to access this data. And anytime we do that, we always provide the caveat, like, hey, when in doubt, give us a call. We're out in the field all the time. We're happy to come out and just, boots on the ground is always the best way to determine whether or not, a jurisdictional resource is present. But then there are the individuals, where maybe they don't have access to a computer, or they don't have, aren't comfortable navigating in a GIS setting. With those people, we work to extract the data in a format that's more palatable with them. Also, like I know with towns I've worked with, I've actually printed out small quadrants of just overviews of their town, so that they can see, they can, some of them pin them to their wall. It's their wallpaper on their wall. So we approach it in different ways and different people and different situations. So it's, we're doing our best, but in the end, I think it's been a very valuable tool for us and for the people of Vermont.
Yeah, that's maybe I'm glad you mentioned the other stakeholders than just an individual. Like that was what I was thinking about. As a frustrated individual. But when you have loggers, municipalities, and like I said, realtors and things like that, you have a lot of folks with vested interest in, and yeah, they're going to be, as groups, they're very proactive sometimes in getting this data.
Right. Yeah. And I mean, developers and like real estate, like those are some of the heaviest users of this. And, in time, they're really picking up on it. They lead conversations off with, hey, saw on the Wetlands Inventory map, something. So it's been really good across the board.
Yeah. Yeah. Anytime you can get a developer thinking green, it definitely helps out.
Yeah.
So, yeah. Julie, I have one specific question, or maybe this is for both of you, regarding land cover classification. What is a quote open end quote land use / land cover?
Oh, you're going to ask me that. It was essentially the barren lands layer. There's I didn't use that data set. The barren lands, there's an open ag land. So any of the open lands, land use, land cover layers were the ones that they used in that original model. So it wasn't forested lands. It was literally trying to capture those open agricultural lands that had the potential to be restored from managed to, in Vermont, as Brock pointed out, probably shrub or forest, not necessarily wet meadow as the peak community.
Okay, all right. And we have a similar classification scheme in Florida land use cover classification system, and I can't right off the top of my head. I can think of a similar classification, but I can't name it. Another question regarding LIDAR. Down here, a lot of LIDAR is flown when during dry periods, so you can get a good some good topography and bathymetry in some cases, and also there I guess quality assurance, quality control with LIDAR in terms of what kind of signal you get from the ground when you have various vegetation cover, percentages. Do you have, has that been much of an issue in, obtaining LiDAR since you've been with the department?
So the wetlands program doesn't specifically contract that out. A lot of the LiDAR data in Vermont is housed with VCGI, the Vermont Center Geographic Information. There are earlier data sets of LiDAR that are not quite as high resolution, and some of the QA/QC protocols just weren't as rigorous as they are now. Since they've flown the state different portions of it at a time or two, I believe we are at full coverage now, which is really great. But it's my understanding VCGI, the Vermont Center Geographic Information, they're the ones, so they house and consolidate it all, and they're the ones who kind of guide and provide the QA/QC to ensure that the data set is either, where there's overlap, it's seamless, or that there's no shifts in the data. And then two, that just their contractors, applying the appropriate protocols for the filtering. And with being so heavily forested here too, I know some of the earlier data sets of LiDAR, the filters in forested settings weren't as high as resolution as the newer ones.
But we can, Brock and I were just looking at an image a couple days ago of a forested site, and if you looked at the LiDAR on it, there were these linear features in there that must have been a stone wall, and our stone walls are a couple feet high, and you're picking that up in a forested setting. We can also see land smoothing and kind of hummock and hollow wetland like micro topography in the imaging. So the imaging is coming out really well, but it's it's the last couple of years. As Brock said, I think the QA/QC effort has really stepped up, and we have really good quality data here.
Cool. All right. Okay, I've got a question. Now I'm figuring out, bear with me, trying to figure out how to ask this, because I know, like, when you are considering restoration projects for phosphorus management, where would a beaver pond fit in the scheme of all this? I know it's not exactly constructed wetlands and not exactly intentional, but would you encourage a property owner to keep his beaver pond?
In terms of a area that is in need for restoration, or more of in the natural environment?
Actually, I may be totally off base, but is a beaver pond, would you consider that as a phosphorus sink, perhaps?
Well, perhaps. I mean, phosphorus retention, as we all know, any nutrient cycling question is, I wouldn't say is a loaded question,
multifaceted.
But yeah. Yeah, because they're like, well, does the beaver load nitrogen, or the fish that are rearing in there? I mean, there's a lot of, I don't know. That's a great question, though. I know we see it in a lot of our restoration sites. With any new saplings or willows popping up, we have no shortage of beavers here, and they're certainly take advantage of that, and they quickly colonize, especially in the lower energy or shrub.
We also have nutrient loads coming from within our stream channels and our banks. We've got sediment laden with nutrients tied up in the sediments, and so if we can keep our stream channels and our ditches stable, and the beaver impoundments can help with that by managing flood attenuation, then that can help. I don't know, I just heard about this. I have a colleague at the Nature Conservancy who mentioned beaver analogs, and looking at some beaver analog work as maybe an option for restoration or something to go along with it. And I don't know much about that, but I'm intrigued and I'm hoping to learn more about it in the next month or so. So that might be something to look into.
Cool. All right. Well, we're getting close to the end of our presentation, and I don't have any more questions available. I would like to once again thank both of you all for presenting today. This is really an awesome GIS presentation. I mean, it's a little state with a big GIS project, you know?
Yeah.
I love it. And,
Thanks, Louis.
sure thing, Brock. With that, I would just like to also mention a couple of things in closing. For those in attendance, the deadline for fellowship applications for wetland ambassadors is January 5th. And if you're not familiar with this, it's a grant for graduate students to be able to study abroad. And so if you visit SWS, our website, then you can get additional information following the link in this slide. And at the end of the month, January 31st, we're going to actually host our first webinar from the Latin American conference of the Society of Wetland Scientists, and that will be done by Ivan Correa. And this will be presented in Spanish. However, on a later date, you will be able to it will be available on YouTube, I believe, and I'm pretty sure they have subtitles there. And also, would also like to let you know that February 21st we'll have a webinar from South Africa, Dr. Elena Rebello, Valley Bottom Palmiat Wetlands, mysterious peatlands at the tip of South Africa. So I'm going to learn what Palmiat is whenever that date comes around. I hope you all will be there as well. So once again, thank you all for attending. And with that, I will end our show.